Hello class, welcome to our second lesson dealing with section 5.1, which deals with the fundamental identities. I'm going to be going through some more examples of moving things around, changing formats, things like that, and then do a few review problems of x, y, and r. First question, notice is cosecant minus sine. Um, all the steps are written here, so I don't know if I need to go over every single step, but I'll at least highlight pieces of each question as we're going through it. You can't combine these two things together because there's a subtraction symbol. So you have to make everything sines and cosines. So 1 over sine plus sine over 1. Please make sure you can't cancel those, though, because there's subtraction in the middle. Find a common denominator. So you're going to have to multiply the second one by sine over sine to get both denominators to be sine of theta. That becomes 1 minus sine squared over sine if you combine that into one term. And then that 1 minus sine squared becomes cosine squared. Now the key to the last step is that cosine over sine is cotangent, but there's still an extra cosine on the bottom, so that's why it ends up being cotangent theta times cosine of theta is your final answer. Next one has cosine out front, probably distributed into the group, so that's cosine squared minus cosine times secant. Notice cosine and secant are reciprocals of one another, so the thought is that that becomes 1 automatically. And then cosine squared minus 1 is not sine squared, it's negative sine squared because it's backwards. It should be 1 minus cosine squared if it was going to be sine squared, but since it's flipped around, it's going to be a negative. The next one, if it looks like it needs to FOIL, it's got a FOIL. It's going to be a really long problem. You notice I almost ran out of space myself on my screen. So you just FOIL everything around, and the key to this scenario is that some of these will become 1. So for example, this sine theta times cosecant is 1. This minus cosine times secant is minus 1. These middle sections, remember, these are small microcosms of what we dealt with last time. So each one of these is its own kind of little problem. And so sine times secant, you say, well, I don't know what to do. Well, make stuff sines and cosines, and this will become sine theta, and secant becomes cosine on the bottom. And that becomes tangent, and then minus its reciprocal, which is cotangent, and the ones cancel. And that's as simplified as it can go for that scenario. But it's FOIL, combine like terms, simplify, change things to sines and cosines. Those are the strategies you want to use. Next one is the Pythagorean identities. If you see something squared plus or minus 1, it's probably one of those things. This will become tangent squared over cotangent squared. That's actually a pretty good answer, tangent squared over cotangent squared. But cotangent squared on the bottom can become tangent squared on the top, which actually makes it tangent to the 4th power. So really, this question doesn't take that many steps in order to find the answer, but tangent squared over cotangent squared will automatically become a tangent to the 4th because cotangent can move to the numerator by doing the reciprocal identities. The next one, remember, if you see something squared with a negative angle, you can essentially ignore the negative sign. If the squared wasn't there, you have to use the odd-even functions. But what's important here is that sine squared plus cosine squared will become 1. So sine squared theta plus cosine squared theta will be 1. And then this is negative secant squared plus 1, which is the same as negative tangent squared. I showed a little bit of work about why that is the case over here. So 1 plus tangent squared equals secant squared, and it's just manipulation and moving things around from the equation in order to get negative tangent squared. Okay, reviewing how to find x, y, and r. Remember, set up in the quadrant. Cotangent says it's negative 3 over 4, so that's adjacent over opposite, but the y value or the opposite is the negative one. Pythagorean theorem to find r, and then sine would be y over r, or opposite over hypotenuse, negative 4/5. Remember, some questions may ask you to find all of them. Other questions may just ask you to find sine of theta. Next one, tangent root 6 over 2, and it's negative, but cosine is positive, so that means it has to be in quadrant 4 with the all students take calculus approach. The negative is the root 6 then, Pythagorean theorem, 4 plus 6, and then root 10 is your answer for that part. You rationalize the denominator, negative root 6 over root 10 becomes negative root 60 over 10. But don't forget you have to simplify here. 60 is divisible by 4, and so it's actually negative 2 root 15 over 10, which simplifies down. So you want to make sure that when you're looking at those questions, you rationalize the denominator and simplify it. That's probably ends up being the hardest part of the question for a lot of students. So make sure you're working on that idea, and don't forget your negative sign because you're in quadrant 4. Okay, just to remind people about some first steps, I thought that might be helpful as you're looking at simplifying trig identity questions. If you have a lot of stuff with multiplication, the goal is make things sines and cosines and then simplify. If you see something out front, it probably is distribute it and then make things sines and cosines, and it might use a Pythagorean identity as well if you get something squared plus or minus 1 in the question. If it looks like it needs to FOIL and distribute, it probably does. So in this question here, you would distribute everything, and then you would use the other strategies from the previous slide with sines and cosines, Pythagoreans. If you see division with something squared, it's probably a Pythagorean identity. And then don't forget your reciprocal identities. So if you see identities, excuse me. So if you see cosine on the bottom, it could become like secant on the top, for example. And it's just an elevator. So if it's on the bottom, it's going to move to the top. If it's on the top, it's going to move to the bottom. And that's how the reciprocal identities will work. Please make sure you are careful about negative signs, especially with the Pythagorean identities, making sure you get rid of division if you can, foiling, and it's probably going to be difference of squares like this one on the left side here. Those are the main strategies in order to figure out trig identity problems. Honestly, if you just have a few examples, that should probably correlate to what you're looking at on your homework, and I think that'll probably be helpful as you're going through those scenarios. Have a good day, everyone.